Okay, so how it's going? Can you solve the problem and find the final answer? If not, then it's okay. We can work together. So now I just retry to sketch it again to have a better idea of what's going on. So you can see here, this is the large fish, the predator. I would just have it as the object 1, so it have the mass m1. And at first it's travel horizontal, right, to the right, from west to east. And this is the initial velocity. And this is the second fish. This is the little one. And it's travel from top to the bottom, or from the north to the south, this way. So I would say that after they meet each other, snap, that there will be the collision. And after that, the little fish will be inside the large fish. So we can treat both of them as a whole body. Now we need to find the V here, right? So see, that's what I'm trying to draw it. Whenever I work with momentum problems, I go just draw everything that happened before the collisions and then what after the collision to get a sense of what's going on. So here, in order to apply conservations of momentum, we should have a sense of what is a momentum, right? So what is a momentum? Momentum is another vector that's proportional to the velocity vector. So they should be in the same direction. It's just different in the length. So here we can see that this is the little vector. And for this one, the mass is 11.5 kilogram. So I could say that the momentum should have the length 11 point times the velocity. You can see that it's longer, right? Still in the same direction towards the right. And then we apply the same for the fish, the little fish here. The mass is just 1.25 kilograms, so it's just slightly longer a little bit and still in the same direction. So now we have the initial momentum of the large fish and also the momentum of the little fish initially. What should we do next? We should have them added together, right? Because it said that the total momentum before will equal to the total momentum after. So in order to add these two vectors together, we can apply either the method head to tail or the parallelogram. So I can help you to remember a little bit about both of the method. Let's try the first one. In order to do the vector addition, we just need a copy of each vector, right? Because we don't want to change the directions of the vector or change the length of it. You can see that they match, right? Because it's just a copy of it. And then I will just do the same for the second one. I will also copy and then paste it. Okay, so if they say a head to tail, it means that you should have the head of the first vector that meets with the tail of the second vector. So if I bring this one on like this, you see they made each other for now, right? And then we will have the addition vector will be from the tail of the first vector to the head of the second vector. So it should be in the shape something like this. It's just a sketch. That's the head to tail method. If you don't want to use this method, you can use the parallelogram method. So what is it? It just means that instead of bringing the head of this one to the tail of this one, which you can just bring those two tails together like this, and then we can just make another copy of this one because we need a parallelogram. A parallelogram basically is a geometry shape of two pairs of parallel sides, right? So now we can see, and this is kind of is a special parallelogram because it's a rectangle. And then after that, we also have the addition, the resultant vector, the result to be from the tail to the head of both vectors. Okay, so this one I will add the arrows here to show the direction. So this one is the result, you see. It can either this way or, you see, if we apply both methods, it will be just the same thing. So now we got, this is the final momentum. right? This actually is the momentum net, and we know that before and after they just be the same. Okay, so yeah, do you get it? So this one actually is the momentum of the whole system here that combine of the two fishes, right? And now if we got the momentum of it already, can we find the speed? Yeah, right? Because we will have the the momentum net will be the m1 plus m2 times together with the v, right? So if we know this one already, can we find the v? I believe so. Okay, so I let you try give you another chance to like complete this one based on the suggestions up to this point. And then in the next and the final video, we will find the final answer for this problem. Okay, thank you. Good luck.